In this chapter, we're going to explore the distributive property and its applications. The distributive property is a very useful expression transformation technique. The distributive property states that A times B plus C is equal to A times B plus A times C. In other words, we can distribute A to B and C. The distributive property can be visualized in the following graph. The width of the orange rectangle is B and the height is A. Thus, the area of the orange rectangle is A times B. The width of the blue rectangle is C and the height is again A. Thus, the area of the blue rectangle is A times C. Then the total area is A times B plus A times C. Since the height of both rectangles is A, we made a larger rectangle by placing the two rectangles side by side. The width of the larger rectangle is B plus C, and the height is still A. Then the area of this larger rectangle is A times B plus C. The area of the larger rectangle is also the area of the orange rectangle plus the area of the blue rectangle. In other words, A times B plus C is equal to A times B plus A times C. Here are some examples of the distributive property. 3 times 4 plus 5 is equal to 3 times 4 plus 3 times 5. 10 times 2 plus 21 is equal to 10 times 2 plus 10 times 21. X over y times m plus n is equal to x over y times m plus x over y times n. If two fractions share a denominator, we can add them by adding the numerators. For example, 1 over 6 plus 3 over 6 equals 4 over 6. In general, A over C plus B over C equals A plus B over C. Let's prove this theorem. We can use the distributive property to claim that A times 1 over C plus B times 1 over C equals A plus B times 1 over C. Then we can reach the conclusion by simplifying this equation using the following property. A times 1 over B equals A over B. Let's prove that A plus B times A plus B is equal to A times A plus A times B times 2 plus B times B. Here's another way to write the same theorem. A plus B squared is equal to A squared plus 2AB plus B squared. And here's a visual representation of this theorem. The area of the orange square is A times A. The area of the blue rectangle is A times B. The area of the green square is B times B. Then the total area of one orange square, two blue rectangles, and one green square is A times A plus 2 times A times B plus B times B. This graph shows that we can arrange the four rectangles into a larger square. The side of this larger square is A plus B. Therefore, the area of the larger square is A plus B times A plus B. The area of the larger square is equal to the area of the four rectangles. So we claim that A times A plus 2 times A times B plus B times B is equal to A plus B times A plus B. This theorem can also be proved fairly easily using the distributive property. Let's prove the following theorem. A plus B times negative 1 times A plus B times negative 1 is equal to A times A plus A times B times negative 2 plus B times B. This theorem is equivalent to the following. A minus B squared equals A squared minus 2 times A times B plus B squared. And here's a visual representation of the theorem. In this graph, the side of the largest square is A. The longer side of the blue rectangle is B. Thus, the side of the orange square is a minus b. The area of the orange square is a minus b squared. The area of the orange square is also the area of the largest square minus 2 of the areas of the blue rectangles and the area of the green square. The area of the largest square is a squared. The area of the blue rectangle is b times a minus b. The area of the green square is b squared. Thus, the area of the orange square is a squared minus 2 times b times a minus b minus b squared. Using the distributive property, 2 times b times a minus b is equal to 2ba minus 2bb, which is 2ba minus 2 times b squared. If we substitute this expression into the larger expression, then we get a squared minus 2ba minus 2b squared minus b squared. This reduces to a squared minus 2ba plus b squared. We can also prove this theorem using the sum square theorem, which also used the distributive property. Let's prove that a times a plus b times b times negative 1 is equal to a plus b times a plus b times negative 1. This theorem is equivalent to a squared minus b squared equals a plus b times a minus b. Here's a visual representation of this theorem. In this graph, the side of the largest square is a. The side of the orange square is b. Thus, the longer side of the blue rectangle is a minus b. The difference between the area of the largest square and the area of the orange square is a squared minus b squared. Notice that if we remove the orange square from the largest square, then we're left with 2 blue rectangles and the green square. The total area of the 2 blue rectangles and the green square is 2 times a minus b times b plus a minus b squared. If we factor out a minus b from both terms, we get 2 times 1 times b plus a minus b times a minus b. 2 times 1 times b is 2b. So 2 times 1 times b plus a minus b is a plus b. Therefore, the area of the 2 blue rectangles and the green square is a plus b times a minus b.